Welcome to the DIY Honda Garage channel. DTC P0016 refers to the CMP sensor A and CKP sensor correlation issue in Honda Civics, manufactured between 2016 and 2021. This error indicates a correlation problem between the camshaft position, CMP, sensor A, and the crankshaft position, CKP, sensor. These sensors are crucial for the engine management system as they help determine the engine's timing for optimal performance. The CMP sensor A is typically located near the intake camshaft, and the CKP sensor can usually be found near the crankshaft. If these sensors do not report accurate positions, the engine control module, ECM, cannot optimize fuel injection and ignition timing, leading to engine performance issues. Before addressing the issue directly, it's essential to clear existing diagnostic trouble codes, DTCs, and ensure no other related codes exist. The troubleshooting process should also check for intermittent failures by examining sensor connections and wiring. DTC P0016 indicates a mismatch between the CMP sensor A and the CKP sensor. The CMP sensor A plays a vital role in determining the position of the intake camshaft within the engine. Located near the engine's intake components, it provides critical data to the engine control unit, ECU, for accurate timing. The CKP sensor, on the other hand, is responsible for monitoring the crankshaft's position and speed, which directly influences ignition timing and fuel injection. This sensor is typically mounted on the engine block or timing cover. Both sensors work in tandem to ensure that the engine operates smoothly and efficiently. Should either sensor fail or show a discrepancy in their readings, it can lead to poor engine performance, stalling, or difficulty starting. Diagnosing this DTC requires a comprehensive understanding of each sensor's function and accurate location in the vehicle. Several factors may lead to the occurrence of DTC P0016. An incorrect installation of either the CMP sensor A or CKP sensor can result in miscommunication between them and the engine control module. This emphasizes the importance of verifying proper sensor installation according to the manufacturer's specifications. Additionally, a damaged CMP pulse plate may hinder the sensor's ability to gauge the camshaft's position accurately. Issues with the camshaft timing can also trigger this DTC. If the timing is off, the sensors will not align properly. Furthermore, a stretched or damaged cam chain can disrupt the synchronization between the crankshaft and camshaft. Lastly, a failing CKP sensor itself can produce this code, making it essential to test and potentially swap out the CKP sensor to confirm its functionality. The symptoms of DTC P0016 can manifest in several ways, significantly affecting the vehicle's performance. Drivers may notice engine performance issues, including reduced power and acceleration, which can detract from the driving experience. Another critical symptom can be poor fuel economy. If the engine cannot optimize fuel injection due to inaccurate sensor readings, fuel consumption will increase. Engine stalling is also a potential issue, where the vehicle may unexpectedly shut off, leading to dangerous situations, especially in high-traffic areas. Difficulty starting the engine is another common symptom, as the ECU relies on accurate data from the sensors to initiate the fuel and ignition systems. Awareness of these symptoms can help drivers identify potential problems early, ensuring timely intervention and repair. The first step in troubleshooting DTC P0016 involves putting the Honda Civic in the on mode without starting the engine. This mode allows the diagnostic tool, known as the Honda Diagnostic System, HDS, to communicate with the vehicle's computer. Once in the correct mode, use the HDS to clear the stored DTCs. Clearing the DTCs is essential to ensure that data is reset and any potential past errors do not interfere with current diagnostics. After erasing the codes, start the engine. Once the engine is running, you should recheck for any pending or confirmed DTCs using the HDS. This step verifies if the DTC P0016 is still present or if the issue has been resolved, which will dictate the next actions in troubleshooting. The second troubleshooting step requires turning the vehicle to the off mode to prevent any electrical hazards during inspection. Once the engine is powered down, the technician should carefully check the installation of both the CKP and CMP sensors. It is essential to ensure that these components are installed according to manufacturer specifications, as improper installation may lead to erroneous readings. This inspection involves verifying that the sensors are securely fitted, oriented correctly, and free from debris or obstruction. If the sensors are found to be incorrectly installed, the technician needs to reinstall them appropriately. Successfully confirming that both sensors are installed properly is crucial for accurate readings and will allow for further steps in the troubleshooting process. In the third troubleshooting step, the technician must remove CMP sensor A to gain access for inspection. After removal, a detailed visual check focuses on the CMP pulse plate A, which is essential for the sensor to function correctly. This plate can become damaged through wear and tear, or it may have abnormalities that could lead to misalignment. If the pulse plate is observed to be damaged, it necessitates replacing the entire intake camshaft, since this component is integral to the timing and operation of the engine management system. Conversely, if no damage is identified on the CMP pulse plate, the technician can proceed to check the camshaft timing. The integrity of the CMP pulse plate is vital because any faults here will lead to miscommunication between the sensors and the engine control unit. The fourth step involves checking the camshaft timing, which is crucial for the overall performance of the engine. Accurate camshaft timing ensures that the intake and exhaust valves open and close at the correct intervals, maintaining optimal engine function. This timing should align precisely with the position of the crankshaft, governed by the readings of both the CKP and CMP sensors. If the camshaft timing is found to be off, immediate corrective action is required. Resetting the camshaft timing to the manufacturer's specifications is crucial to restore the synchronized operation needed for the engine to run efficiently. If camshaft timing is confirmed to be correct, the technician can proceed to the next troubleshooting step to further diagnose potential issues. In the fifth troubleshooting step, the focus shifts to the cam chain, which connects the crankshaft to the camshaft, ensuring both components operate in harmony. This chain must be in excellent condition. Any signs of wear, such as stretching or damage, can lead to misalignment between the crankshaft and camshaft readings. A thorough inspection involves looking for fraying, elongation, or any physical damage on the chain itself. Should the cam chain be found damaged or excessively stretched, replacement becomes necessary. This also includes replacing the cam chain auto tensioner, as this component helps maintain correct tension in the chain for optimal performance. Cam chain integrity is vital for reliable engine performance, and addressing any deficiencies in this component is critical for the successful resolution of DTC P0016. In the sixth and final troubleshooting step, the process involves substituting a known good CKP sensor. This is crucial to determine if the original CKP sensor is the root cause of the DTC P0016 or if the fault lies elsewhere. After replacing the CKP sensor, it is essential to reconnect all connectors properly to ensure good electrical contact. Once everything is reconnected, switch the vehicle to the on mode again, allowing the HDS to communicate with the vehicle's systems. Clear the DTC using the HDS and then start the engine as a final check. After starting the engine, recheck for any pending or confirmed DTCs. If DTC P0016 persists, it indicates that the CKP sensor is functioning correctly, and further investigation should focus on service information for related symptoms or possibly substituting a known good engine control module, PCM. If the original CKP sensor is the culprit, it must be replaced. After completing the troubleshooting and repair process for DTC P0016, it is essential to verify that the repairs have been successful. The first step is to confirm that the diagnostic trouble code has been cleared from the system using the Honda Diagnostic System HDS. Once confirmed, it is time to evaluate the engine's performance to ensure that it runs smoothly without any irregularities. Monitoring for any recurring symptoms such as stumbling, stalling, or poor fuel economy helps verify that the issue has been fully resolved. It's also wise to conduct a test drive under various driving conditions to ensure the vehicle operates correctly. If the vehicle performs well without triggering any new diagnostic codes, the repair is likely successful. Preventive maintenance plays an essential role in avoiding issues such as DTC P0016 from arising. Regular inspections of both the CMP and CKP sensors can help catch any potential issues before they escalate into larger problems. Additionally, routine checks of the camshaft timing and cam chain condition ensure that your engine remains in optimal working order. Scheduling maintenance at recommended intervals according to Honda guidelines allows for timely replacements and adjustments. Proper care of these components can significantly enhance the vehicle's reliability and performance. Furthermore, maintaining electrical connections to sensors can prevent intermittent failures that lead to confusing DTC codes and costly repairs. In conclusion, resolving DTC P0016 requires understanding the roles of the CKP and CMP sensors and their significance within the engine's management system. Each troubleshooting step serves a distinct purpose in diagnosing the issue, from verifying connections to inspecting component integrity. It is crucial to follow the detailed steps laid out in this troubleshooting process carefully to ensure accurate diagnosis and successful repairs. Additionally, implementing preventive maintenance measures can help avoid potential failures and keep the vehicle running smoothly. Early detection and prompt action can save both time and resources, ensuring that the Honda Civic maintains optimal performance for years to come. Please like and subscribe to the channel. See you next time.